Hello everyone, in this video we are going to see how to find a prime number. If you are given a number, we have to find whether it is a prime number or a composite number. We are going to use Python programming language for doing that. Now let us see what's a prime number. A prime number is a number which can be divided only by itself and 1 without any remainder. So example here is 17. 17 is a number which can be divided by 17 and 1 without a remainder. If you divide by 2 to 16, it will always leave a remainder. So some examples are 2 is the only even prime number, you have to remember that. 2, 3, 5, 7, 11, 13, 17, 19, 23. These are all prime numbers. So prime numbers are basically a number which can be divided by itself and 1 without any remainder. So we have to find whether a number is prime or not if you are given a number. So there are many methods for that. So we are going to use first method. It's a roundabout way, so we go on refining. So first we'll get a number which is more than 2, because 2 is a prime number that we are leaving. 0 and 1 are not prime numbers, so the problem starts from 2 only. So we are leaving 2 because it's a even prime. So from more than 2 numbers we will be working out. So you get a number which is more than 2, then divide the number starting from 2. That is, denominator is 2 to n minus 1. So the number is n. You start dividing the number from 2 and the divisor iterates to n minus 1. So if any division gives out a remainder 0, then you have to stop immediately. Then you have to just say it's a composite number. That means it's not a prime number. So the divisor goes from 2 to n minus 1. The number is n. Okay. So this method we will implement in C. So we'll ask the user to give a input. We'll typecast it to integer and we store it in num. We'll just give a message to the user to enter an integer which is greater than 2. Just a message. So once we got the number, as you see in this one, divide the number starting from 2. It's not starting by, it's starting from 2 and iterating to n minus 1. So we got the number, so we will be dividing the number. So number divided by 2. So we can just, we are checking the remainder. So we just say if the number is divided by 2 and if it leaves no remainder, that is 0 remainder, then it is not a prime number, it's a composite number. That's the meaning. So then we just move the divisor to 3, then 4, then 5. It just goes like that up to n minus 1. Okay, so we'll just, for the say as in the algorithm, we just say n is a number. We just starting to divide by 2. So we'll just say divisor equal to 2, then we just say divisor. So this is the divisor, the denominator, the numerator is the number n. So we are starting from 2, and if it is leave out 0, then we are stopping. Okay, so if this is the case, then we have to just say it's not a prime number. So for that, I'm going to maintain a flag. Say for example, there is a flag. I'll set the flag to 0. Initially the flag is equal to 1. So if the flag is 0, then we say it's a composite number because it is divided by a divisor and that leaves a 0 remainder. So basically if flag equal to 0, then we say it's a prime. else we say it's not a prime. It's not a prime. So basically this is the idea. So first we are dividing the number by 2. Imagine I'm entering number 21. Okay, so the entered number is 21. So here we are entering the number is 21. So we start the number by dividing it with 2. We didn't get a 0. Then we have to increment the divisor. That's the idea. So since we didn't get it, we have to just do a incrementation by 1. Divisor is incremented. Then you have to just go on doing this divisor incrementation up to n minus 1. So this should be put up in a loop. So I'm using a while loop here where the divisors will be seen. So divisor is less than or equal to, goes up to n minus 1. That's the idea. So the divisor starts from 2. If it is 21, it goes up to 20. You are going to divide this number 20 from 2 to 20. So the divisor, whenever it is dividing, whenever if it's getting 0 reminder, that means the whole number comes out of the division, we just set the flag to 0. Then we have to break the loop. So it will not go further, it will not increment the divisor. That's it. So we got the number n and the divisor starts from 2. Initially the flag is set to 1. If the flag is 1 always, that means this part is never executed, then that's a prime category. So if it is equal to 1, if it is equal to 1, it's a prime. If it is equal to 1, it's a prime. Else it's not a prime. So first we set it to 1, then it's keeping 1 always unless it hits this place. So initially we are dividing by 2. It's not equal to 0. Is it equal to 0? No. That means it will not enter here. It will increment the divisor. Divisor becomes 3. So we are dividing the number n, which is 21, by 3. That's also will give a reminder 0. So in that case, the flag is set to 0. Then break will be hit. It will come out, and it sees this one. It's a change. Now it will print. It's not a prime. So this is the way. So if you are entering number, imagine 49. 49. First we are dividing 49 by 2. So false. Then increment the divisor, 49 by 3, false, it is not equal to 0. We are incrementing to 4, then again it's not equal to 0, incrementing to 5, not equal to 0 in this case, incrementing to 6, we cannot divide, and then incrementing to 7, the 7 will divide, it will give out a 0 reminder. We set the flag to 0, we are breaking. So we don't go all the way up to 48. 7 is dividing, we just come out and print it. Okay, so this is a way of finding. So now we'll enter. If we say 49, it's not a prime number, friends. So if you're entering 101, it's a prime number. 101 is a prime number. So likewise, I enter 179. It's a prime number. I enter 181. Again, it's a prime number. We enter 201, 201. It's not a prime number because it is divided by 3. So this is method 1. We got a number and we are dividing the number from 2 to n minus 1. So if any division gives a remainder 0, we just set the flag to 0. Based on that, we are just printing whether it's prime or not. So if anything gives a remainder 0, we are breaking immediately from the loop. We don't go all the way up to n minus 1. Okay. Now we are going to modify the same code for method 2. The method 2, get a number which is more than 2, that is fine. Divide the number by 2. Sorry, we'll go to method 2. Divide the number by 2 and then iterate till n by 2. Say if the number is 49, then this number cannot be divided by a denominator which is more than the half of the number without leaving a remainder. It will always leave a remainder. So if you see this one, 49, so it is 24.5. 24.5. Just keep it 24. That is a 24.5. Then 24 is less than 24.5. Or if you just say 25. From 25 onwards, the number 49 will never be divided by the denominator which is more than 25 without leaving a remainder. That means remainder will always be there. Remainder will never be equal to 0 after and from 25 onwards. If you see this 49, in 49 cases 24.5 is the half of the number, then we just have to go up to half of the number. There is no need to go up to the n minus 1. So here we are going to change it up to by 2. So if you are doing this by 2, it will give the quotient to me. So if the number is 49, we will divide the number by 2. So it is 24. It will leave out 24. If I put a single slash, it will give me 24.5. This is also fine because divisor is an integer. We are incrementing. One time it will go up to 24. It will not go in this case. Let us just assume it goes to 24. But if it crosses 25, that means it will be crossing this 24.5. So it will not be divided by 25. It will divide up to 24. Or it is better to just go with a double slash. So or I can put a divisor limit. You can just say this is a divisor limit because then every time it will not calculate this. So we can just have one variable divisor limit. Divisor limit goes up to n by 2. So I can put this divisor limit here. So now we are going to divide the number n from 2 to n by 2, not n minus 1. So this is the method 2. If we enter 49, it's not a prime number, let's say. So if you are entering say 51, 51 is also not a prime because it is divided by 3. If you are dividing by 101, sorry, if the number is 101, 101 is a prime number. Let us see how the divisor goes from 2 to which number it goes. If you want to see that thing, we'll just print the divisor. Print the divisor for 101. We'll just execute. The number we are entering is 101. It just goes up to 50. 101 is 50.5, but the divisor goes up to 50, not more than 50. So that is what we need. So that's the method 2. It will save some time. So this is another way to find prime or not. The method 3, here also we just get a number which is more than 2. First we will divide the number by 2. If it gives out a whole number, then the number is composite. That's fine. Then we start from 3 and we go up to n by 2. That is fine, as like a method 2. But the one thing we have to remember here is we are not going to divide the number with even numbers which is more than 2, because once you try with 2 and if the number is not dividing by 2, That means it is not leaving a whole number. That means you don't need to divide by 4, 6, 8, 10, 12 like that. So for example, I enter the number 49. I am trying to divide the number 49 by 2. It's still leaving out a remainder 1. That is, it is not getting divided by 2 without a remainder. So I'm going to proceed further. So while proceeding further, instead of starting from 3 to n by 2, we are going to do a certain modification in that range. We are going to leave the even numbers in the range. After 3, 4 comes, I will not divide the number by 4. Why should we divide the number by 4? Because it is not divided by 2. That means it will not be divided by 4 because 4 is divided by 2. So there is no need to try the even numbers that comes after 2 till n by 2. So this modification we are going to do. So here first we will divide by 2. So in that case, if we just put a thing, if numbers percentage 2 is equal to 0, or in this case we just put a flag equal to 0, flag equal to 0, else we are doing this. So flag equal to 0, it will just go here. It just says it is not a prime number. So once the number is not divided by 2, we are coming here. So the divisor starts from 2. We say now we are going to start the divisor from 3. So divisor equal to 3. 3 onwards we are going to do. So the divisor limit we have to see, that is fine. Divisor limit is same. We are going to say with the start with 3 because we already tried for 2. Then once in the range we just have to divide only by odd numbers. Say once you are trying to divide by 3, you should not go with 4. You should go with 5. That means I should increment the divisor by 2. So by doing that, we are doing a device checker. So number 49 is entered. For example, 49. 49 is not divided by 2. So flag will not be set to 0. It will come to else part. Else part, we are starting the divisor from 3. So this is divisor 3. So 3 is less than 49 by 2. That is 24. Yeah. So we'll enter inside. So we are trying to divide the number by 3. It's not equal to 0. So that means it will not execute this one. It will go here. So it is 5. Now we try to divide by 5. That's also not leaving a 0 remainder. Then 7. Then 7. 49 by 7 will give us 0 remainder. So it just comes out. Break statement is executed. It comes out. Flag is 0. It says it's not a prime number. Okay. So what we are saving is, we are saving some divisions. Why unnecessarily divide by even numbers in this range? Because it is not divided by 2 in this category. Okay. So let us run this code. That's a method 3. 1 at 1. It's a prime number. So you want to see the devices. What are all the devices here? Just print the devices. So the devices are, you see, only odd numbers, 27, 29. So it starts from 3 to 5, 5, 7, 9, 11. It is going on dividing up to 49. Up to 49. So we are saving some divisions here. We're saving some time by not executing some divisions. Division is a very costly operation. So this is method 3. This is the method. So I hope you have understood this, all these 3 methods of solving prime number finding. But one more thing is there. That is what is used in many places. In competitive coding and all, they will use that thing only. Let me see. What is that? So the only prime number is 2, that we all know. So this can be handled by a separate if condition. If the sum of the digits is a multiple of 3, then the number will be divided by 3. This you have to remember. So if you are given a very big number, so instead of start trying with divisions, you just sum up the digits of that number. You got a very big number, you sum the digits of the number. If the digits of the number is a multiple of 3, the meaning if the sum of the digits of the number, that integer, if it is divided by 3, okay, if it is a multiple of 3, then it will be divided by 3. Then the main number is divided by 3. So for example, we will just have a number like this, one very big number. So we have 9 to 11, 20, so 11, 20, 22, and then 31, then 2. So the sum of the digits is 9, 2, 9, 2, 9, 2. It is 11 plus 11 plus 11, it is 33. 33. Sum of the digits of this one is 33. So this 33 is a multiple of 3. Then this number will be divided by 3. That's the meaning. So if the sum of the digits of the number, if that is divided by 3 without leaving a remainder, then this number will also be divided by 3 without leaving a remainder. So this check is the one thing we can use it. Then no prime numbers greater than 5 ends in a 5. No prime number which is greater than 5 can ends in a 5. Say for example 15 is a number greater than 5 but it's ending in a 5. So it can never be a prime number. So numbers which are ending in 5 and more than 5 will never be a prime number. 5, 25, 35, 45, whatever the number it is. If it is ending by 5, 125, 2, 3, 4, 5, 6, 7 ending with 5, whatever the number, very big number it is, if it is more than 5 and ends in 5, that number will be divided by 5. Okay, so these are all things we can use it to solve it quickly. And one more thing, this is the way people used to solve it in a competitive programming. So if you are asked to find a number where it is prime or not, and if it is going to be so huge number, that means you should not approach the division in the same way we have done. You should be saving the time in this way. Say first they will divide the number by 2. If it leaves a whole number, then stop it. It's not a prime number, it's a composite number. If it is not divided by 2, then you have to start dividing the number in question by the prime numbers only. 3, 5, 7, 11. These are all prime numbers. Not even odd numbers. 9 is missing. You see? Because 9 is divided by 3. 9 is divisible by 3. So you should be dividing the number by 2 first. If it is not divided by 2 without leaving a remainder, then start dividing the number from 3, starting from 3, which is a prime number, up to the half of the number. You just select the prime numbers alone as the divisors. So this way we can solve more time. So anyhow, in this examples problem solving, we just saw this one. In the first method, we started dividing from 2 to n minus 1. The second method, we started dividing from 2 to n by 2. The third method, we are dividing by 2. If it is not divided by 2, then we start from 3 and we select odd numbers till it reaches n by 2. This is all devices we are talking about. So I hope you understood this code. I hope this video helps in finding the prime number in an efficient way. Thanks for listening.